Jason Mattox is going to talk about our architecture and how this runs in an environment. We have a VHD option. We also will have a VMDK option that can speed things even further. So I'd like to introduce Jason Mattox again, our CTO.
Thanks, Jason Smith. So I want to take a few minutes and cover kind of core ProfileUnity architecture. And also we'll talk about the differences of delivery and application layer on a VHD versus a VMDK. So when you look at this architecture slide, on the far left, you've got the ProfileUnity web console. And on the first file server, we have the ProfileUnity kind of stack that sits on a file share. What we do is we leverage the most highly available file share a customer might have as an option. We leverage the net logon directory and or any other high available file share that they have. And on this file share, we put down ProfileUnity policies and configurations along with our agent files. This ensures that if you're using something like the netlogon file share as a single namespace, that everything can be installed across every machine in the infrastructure. Every machine can also pull down its policies, and users can pull down policies as well in a highly available, scalable way, because AD is usually scaled out to meet the customer demand locally and remotely across sites. Optionally, you can use some other high available file share without an issue. We have another file share where we store user profiles. We take the user profile and we put it into a compressed, highly accelerated format that we can apply during session or log in or log off, you pick. That's not the primary focus today, but it's part of the infrastructure. And then we usually leverage the existing user home directories the customer might have within that environment. Again, that user profile is available to go across physical, virtual, ZenApp, XenDesktop. It doesn't matter the operating system for us. We can make that profile hybrid. We're doing a lot of 2003 migration still from older versions of ZenApp or Metaframe, for customers as well. And then there's another file share that we leverage for the VHDs that would then be for application layering. We have a user installed application VHD, and we have a departmental application VHD, and we have a profile VHD. So these VHDs can exist on their own dedicated file share. You could move the profile VHD to be in the existing home directory share if you'd like. What's interesting about this entire infrastructure, as we leverage VHDs and we write down the policies and configurations of what users get what application layers and what users get what profile layers applied to their desktop, VHD is an in the guest function. It doesn't require any specifics with the hypervisor. So it'll work on Hyper-V, it'll work on ESX, it doesn't matter. In this configuration, I can take the ProfileUnity console and completely turn it off. The policies and configurations have been applied to a replicated file share with a single namespace that's highly available. So now when a user logs in, we know that they need a profile disk. When a user logs in, we know that they get these 5 or 10 VHDs that make up their 5 or 10 application layers that they need to be played back into the operating system virtually. So this allows us to really leverage an existing infrastructure without requiring a lot more servers to be online. And we talk about VMDKs on the next slide in a minute. That's going to change and how we can deliver. So we can mix and match VMDKs and also VHDs. I've seen a little bit of a slight delay on some of the application loading, but again, once it's cached, Windows will create a superfetch and cache each, kind of file system reads into memory to accelerate the second open of the app on a VHD. And I know that in the Citrix environments, customers use a lot of VHDs for different reasons as well. The VHD is an in the guest function, so it works across physical, virtual, of any broker, any delivery, any hypervisor. Okay, so this talks about the VMDK option, and this is where we have to have servers online and available because we have to issue API calls against Virtual Center, similar to how MCS does. We look at this infrastructure on the top left to the bottom right, kind of at angle. We have our ProfileUnity installations, the primary, secondary, and tertiary installations. We install ProfileUnity 3 times on 3 different Windows 2008, 2012 R2 machines. At that point, we then tell the primary node about the second, third, fourth, fifth, sixth, seventh, or even 10th node. It automatically establishes a highly available cluster. There's no need for SQL clustering. There's no need for an F5 load balancer in this configuration. We have the ProfileUnity console in the top left of the stack. then we have the FlexDisk service. The FlexDisk service is responsible for talking to Virtual Center and issuing the hot add and removes of VMDKs that make up the app layer or profile layer for the user. We have the Fabric. The Fabric technology is designed to avoid any machine talking directly to any of the ProfileUnity installations to avoid failure. So for example, when a user logs into a desktop, a message is sent to the Fabric. It's then replicated across all the orange Fabric blocks that you see. FlexDisk then pulls the message off the Fabric, then processes what belongs to that user. You get these 5 disks, 6 disks added to your desktop for your application layers. This is a pull architecture instead of a blind push architecture or old school client-server architecture. What that means is when the desktops submit the message to the Fabric, it's self-replicated, whether I have 5 nodes or 10 nodes. FlexDisk will then participate in pulling the message off the Fabric. If it pulls it off the Fabric and doesn't process that message, in a period of time, a different node will pick that message up and process it. So there's no incomplete. I can shut down nodes in the middle of logins and still recover from a failure in that way. I can also do rolling maintenance outages if I have to as well and still recover. The point being is if I pull down a single FlexDisk service for maintenance or upgrades, it just doesn't participate. Competing products will send information blindly to the other side, hoping the NT service is available, has retries and timeouts built in to accept. In this situation, the Fabric is highly available, highly designed clustering system to accept those messages, and if a node is down in the cluster, it just doesn't participate in replication of that message. And then if FlexDisk is down, it just won't go grab the message off the Fabric. The last one is the database. We provide the database, and we provide the clustering of the database. It's a NoSQL self-cluster database that we maintain for you. This is all designed to be a point-and-click fashion. The other thing to note about this design as well is both the VHD design and the VMDK design support the active-active desktop. Customers are driving towards leveraging their DR sites as an active-active desktop more and more. They don't want to have warm sites or cold sites where hardware is just wasting away. They'd rather have the ability to move between sites completely seamless to the user. And with this configuration, because we leverage the object model of Virtual Center, all of our disks that we create are managed by virtual hardware, and we can format and manage those disks remotely. We don't need special template disks to be uploaded. We don't have rogue VMDKs out on the storage device. We actually have them attached to virtual hardware. So then if you had an active-active situation, you could use something like a Nutanix or a NetApp and replicate the volume to another site, attach it as a read-only data store, and we can actually import those same Virtual Center objects because the VMX contains the metadata we need, and then we can make those same applications that you packaged one time at the primary site, replicated to a secondary site, available at both sites. So you package once, deliver many cross-site. So we're targeting active-active design support out of the box, which is a big thing that I've talked to some enterprise accounts recently, and this is kind of a showstopper when it comes to kind of an app volumes type solution. So what I wanted to show here a little bit is the management console and then the user experience as well. So when we look at the management console and how we can deliver applications to a user, we have this control panel type look where I basically have existing applications that I packaged for a user. I can go ahead and I can add a rule for the existing applications that I've packaged. We basically drag and drop these applications in. We select a filter and how we want to apply this filter. And the filter can be IP address range. It could be username, group, OU, LDAP information for schools or healthcare. There's almost 300 different ways that I can decide that the filter is going to be true or false and whether or not a user should get an application. Now, the differencing disk path that you see there, that's a temporary write cache. The application is fully read-write to the operating system. The differencing disk is created in the user's temp directory or on a file share, and it's thrown away at logoff. So it's a truly non-persistent application layer delivered to the desktop that's consistent every time. One thing I didn't cover, just as a review, is the application layering technology that we're providing is an application layer that's native to the operating system. It's not isolation. There's a point for isolation when it comes to an app V, when you need to have 2 versions of Internet Explorer, to versions of Java, or to apps that conflict. This is a native application. So in our situation, we work with drivers, we work with services, printers, all the complex things that exist out there in applications. And we have the ability to provide all of these things at a user or machine level, either one. In App Volumes and other products, they tend to do a lot of machine level assignments because they have difficulties in their design. Our design is built in a way that we can leverage all of our core logic in the user's process, so NT service, and then we have a filter driver that manages the workload of a virtual file system registry or registry key. So virtual file system or virtual registry. So the operating system is not tattooed when we lay down the actual application layer. And this allows us to support many operating systems, 2008, 2012, Windows 8.1, all those different flavors of OS, and support doing things to the application layer, like starting a service, like adding printers into the system. The way that other vendors deal with that is they do everything at the machine level versus the user level. So the sequencing, what we call packaging process, I have a dedicated packaging machine. It's a stateless packager. It pulls all the information from our main API from the system. So you'll see a list of applications pop up here that I've already packaged ahead of time. And when it comes to creating a package and doing application lifecycle management, what I'm going to do here is I'm going to go ahead and create a package, and I'm going to select my delivery type. Do I want VHD or do I want FlexDisk, which is going to be VMDK? Obviously, VHD is going to be a CIF share, and FlexDisk is going to be a VMFS or whatever data store is mounted to my ESX server, basically the virtual center visible to virtual center. I can select whether the disk is fixed or expanded. In this process, once you create a package, you can edit a package, you can clone a package between VMDK to VMDK or VHD to VMDK or back. So you could do a POC with VHD and then convert to VMDK to experience both the delivery mechanisms, if you'd like. When it comes to kind of maintaining the packages and going forward, part of the issue is, the application's in use by, hundreds or thousands of people. So in that situation, you would likely come in and you would clone the package. You would clone this package to a new package, make your updates to the clone, expire the previous one, and as users log into the system or systems reboot, the new version of the application is delivered. This way, you don't have to do, wait till the weekends just to do package management. You can do package management real time online, and half the users will then slowly migrate and transition over to the new versions of the package. I've even done something here like sysinternals. So sysinternals doesn't really have an installer. It's kind of it's a zip file. And what I've done is I've turned on packaging prior, and then I have just copied in a directory and created my own desktop shortcut by hand. And all those events were recorded to a package so that sysinternals can be delivered to the users. So some applications are just a set of files, they're DLLs, they're a registration, they're a batch file even, or a VB script. And now I've got the sysinternal suite virtually snapped in to my desktop, and I can deliver this to users. And if I stop this package, that package will go away. So here's filter management. I can go ahead and create a filter. And I've got the ability to filter on operating system type, whether it's a log on, a log off event, or a trigger event. And triggers might be application open, application close, a lock, unlock, ICA disconnect, reconnect, all those type of things, process open. And then, I've got the connection type that I'm on. If I'm mixing between RDP and ICA, I can make different decisions for the user. And then I have a set of, filters in here: username, group membership, IP address, host name, MAC address. I've got, TS client name. I've got registry value. I've got file or directory, ICA client name. Is a process running? Is it not running? LDAP, day of week, time of week. So these are all things that I can design a delivery mechanism for. I can decide that, you're not on my IP address range, my corporate IP address range, based on your ICA client address or name, and decide that you're not going to get the applications when you go home. That's just something you're not going to get delivered when you go home. I can pull a registry key that has metadata that I care about. Maybe I pull the registry key that tells me that it's a Windows 8 Surface, and I know that half these applications are not conducive to touch, and I'm not going to deliver the applications that's just going to frustrate, a VP or an executive on a touch device when they should really be using a full PC for it. So you can kind of build these rules and workflows based on if files or directories and registry keys exist, and also lots of LDAP information as well, I think, which is going to help a lot in the EDU space potentially. So the FlexDisk over here on the left, this is where you can deliver a user profile or applications via VMDK. It's a separate service and high available service because it has to talk to Virtual Center and guarantee it can do Virtual Center APIs to deliver those. So I can do machine level assignments and assign things and assign to all pools and assign based on AD group as well. From a ZenApp perspective, this is a ZenApp server here that I'm logged into. These application layers are assigned to the machine. And it's assigned to the machine whether or not it's a published app or if it's a full desktop. In all cases, they're assigned to the machine. We are going to provide VMDK as well, along with VHD for ZenApp. So in a ZenApp scenario, you'd be limited to the number of SCSI IDs available when it comes to a VMDK. VMDK with VMware virtual hardware is 4 SCSI controllers, 15 IDs, 60 possible. So at that point, we can add up to 50, 58, how many ever is not being used by either PVS or MCS or standalone at that point. When it comes to VHD, Microsoft can handle 2,000 block devices within Windows, so we can add as many as you need. Generally, you don't need more than 10 or 20 unless it's an edge case. When it comes to XenDesktop, and I want to go to kind of my desktop environment, in this situation, I can do machine level or user level assignments. I can also mix and match VHD-based applications and VMDK. I can decide if I want to provide higher performance with higher tier storage and do a VMDK delivery for certain apps, but have the lesser, smaller applications, or not worry about application open times being more than 3 or 4 seconds. That's okay. I can deliver VHD based. So I can do either or in that scenario. Take a look here, and we just got a reconfigure event, looks like, in Virtual Center. To just reconfigure my virtual machine, attach my disks. Now ProfileUnity is kicking off processes to make those applications available. In this scenario, I have VHDs and VMDK delivered applications. So here's and one thing I'll show here real quick. And while we're here, is these applications are virtually layered in. The user doesn't know the wiser, nor does the applications or anything else. I got these different directories in here. If I actually go in and we stop the service, all these things will basically vanish from the operating system. So we have a container service that's responsible for all the rule sets of virtual file system and registry on the system. So we can go ahead and stop this service. You'll see all those directories and everything just disappeared off my desktop, and applications are gone. So if we take a look at overall ProfileUnity and what it can do, if we look at privilege elevation is always interesting when we talk about this technology, because this technology for us is core technology of how we run the product. And what that means is when ProfileUnity runs in the user space, percent username percent is their user, we run with administrative rights. So the administrator can come into the product and they can manipulate files under program files. They can manipulate HKLM registry keys. So for example, in my Citrix days back in MetaFrame 1.8, When I did a lot of installations in NT4, I had a lot of bad apps that stored INI files kind of all over the system. They were all over the place. With this environment, I can use the Portability Engine that you see there. The Portability Engine is a set of instructions of files and directories that need to be compressed and push and pulled for the desktop. So I can grab INIs and or files or configurations that are stored in places they should not be stored without the user being an administrator. So if the user needs to have settings stored in C:\Oracle 11G, I can grab those. I can also elevate Oracle 11G so that they can write the settings there in the first place, but I can also back up and restore them without the user being an admin. We don't need credentials on our service to elevate an app to allow that process to be a part of the administrator's group, but also have all the user tokens as well. So it's not for the entire session. There's also hack protection as well. If the user tries to do a file open, browse to system32, *parade*, right-click regedit.exe and try to own the box, that technically is a child process of Word or child process of Oracle. When that happens, we'll see that event and de-elevate that child process and or terminate it. So we've got protection there to kind of manage and deliver safe privilege elevation. Obviously, you don't want to elevate a browser. If you elevate a browser, it's kind of all bets are off because there's so many different ways you can hack the system with a browser. Application restrictions. If there's a set of applications you're delivering, to like a ZenApp to the machine level, we're doing application layering to ZenApp at the machine level, and I still want to be able to control licensing. I can actually add in restrictions for my processes in this way. I can say that the process begins with, ends with, or signed by, or the hash is, for Acrobat Pro. And this way, nobody part of the Acrobat Pro group can run it because this hash will come out and say, if you're not part of that group, the hash of the process is X, you can't run it because you're not licensed. So that'll help enforce licensing and ensure that the user can't dig into the system and open up the app. Virtual disks is just another way to deliver a virtual disk. Profile disk is really where we see a lot of attraction. Having an entire local profile on a VHD or VMDK that follows you from one desktop to another. Obviously, multi-session is a different story, so that it's really dedicated for the users don't really roam much. But if they do roam, you could take the Portability Engine and push and pull settings from each profile disk if you had to. So this is also interesting for DR. A local profile can get very large. So do I want to replicate an entire VHD, or do I want to use the Portability Engine to back up and restore only the parts that I care about for a DR situation? Cookies, favorites, history, shortcuts, passwords, ODBC connections, the basics that I would need in a DR situation. I don't need the entire profile from a DR standpoint, but maybe just the pieces that I need to do minimal work. And one other thing that I'll show really quick, as far as the HA system goes, when it comes to VMDK delivery, I was doing maintenance on my FlexDisk services, and I took them down so I could patch one of them with the current kind of build. And you'll see in the interface here, I've got 2 services down in this situation. The fabric is still up and clustered, and so is the database. But I took down FlexDisk specifically, stopped the NT service, so I could update the binaries. Never started the other 2. And we also have notifications as well. So you can get email notification when services are down, and you can always mute or pause notifications if you're doing maintenance. I keep on talking about the Portability Engine. Let's show the Portability Engine real quick. These are a set of rules we have out of the box for the parts of the profile that you want to back up. But the easiest way to deploy kind of the Portability Engine is under the guided configuration templates. So we're going to add in templates for profile disk as well, and that type of thing. Obviously, with applications, it's a little bit simpler. There's not much configuration really needed. Once you connect the packaging console and start packaging apps, they'll show up under inventory. And once they show up under inventory, you can go ahead and go into the main configuration and assign users applications. We also collect information about applications that are successful. If the user gives us a thumbs up, it's transmitted back anonymously back to our servers, so we can keep a library of applications that are successful in the field as well. So I won't go through everything within this interface, but there's some things that are interesting. When I have to deliver a functionality or a custom script the customer might have delivered, we can do a lot of it within the product. We can do things like do a user-defined script, before or after ProfileUnity at login or log off to do certain things if I need to fix up the environment for some reason, because not every environment's the same, obviously, when it comes to the desktop and applications. I also have application launcher. I can launch different things here. I can provide, system32 cmd.exe/c, and different commands in here, or trib commands or whatever. And a lot of times you can kind of clean up a little functionality the customer is looking for in one or two commands, because you can run this then. And then the nice part about by putting the command in here that you might run is you don't have to have an external batch file on the network the customer has to maintain and secure. It's basically stored within the product itself. Trigger points are always interesting to look at as well when you're looking at how many options I have to control. So every module you saw on the screen can be rerun based on an event that we're looking for. So I can look at lock, unlock, connect, disconnect, IP address change. The user's on a laptop, they go home, they connect to the VPN, we see that event, and then we execute a new policy based off the network. Application open and close, and then computer shutdown. So a lot of different ways that we can apply, which module we have within the system. We can do lots of custom things based on these events. And then we have our own start menu for Windows 8.1 and 2008 server. And then other thing that might be interesting here as well is folder redirection. As you look at a greenfield customer, we can synchronize that user author data in the background with bandwidth control as well. So you don't want 10,000 users or 1,000 users in a migration hitting the network bandwidth all at the same time. So we can synchronize data in the background. Unlike group policy that makes you wait for all the data to be synced, we can sync in the background, then cut over when it's done. We do have the ability to do context-aware printers, so based on filters. So that's kind of the strength we have there, is that we could leverage existing universal drivers as well potentially, and reassign printers based on where the user's at in a college or K through 12, so that the seniors aren't printing in the kindergarten room and stuff like that. We can be context-aware. We just need a little bit of metadata about the environment, either IP address or computer name or some registry key that tells us where the user is, and we can pull that and apply a printer in the right way.